Dear students, welcome to Standard 9 Physics, Chapter Gravitation, Part 4. Content, a calculation of G, variation of G, and acceleration due to gravity does not depend on the mass of a body. So dear students, let's begin with a calculation of G. The small g means acceleration due to gravity. Capital G means universal gravitational constant. Please don't be confused. So here we are discussing about small g or acceleration due to gravity. Okay? Yes. So here I just drop a stone of mass m from a distance r from the center of earth having mass m. So in this case, the force exerted by the earth on the body or on the stone is given by F is equal to G mm by r square. Here capital M is what we call mass of the earth. Small m means mass of the body. R means radius of earth, and the G is called gravitational constant. So the equation which becomes F is equal to G into mm by r square can be taken as equation number 1. So as a result of this force, the stone moves downwards, right? We know that if we throw a stone upwards or we are just releasing a body from a particular height, due to the acceleration due to gravity or the gravitational force provided by the earth, the body or the object moves downwards, right? Yes. So we know that F is equal to ma is another equation. So from this equation we can write acceleration A is equal to force by m. It can be taken as equation number 2. Then putting the value of F from equation 1. So just use this equation or equation 2 and putting the value of F means this value into this equation. So the equation 2 which becomes acceleration A is equal to, instead of F you just want to use this one, gmm by r square. So equation 2 becomes acceleration A is equal to gmm by r square into this m. M is in the denominator. It is here. R square into m. It can be taken as equation number 3. Then equation becomes acceleration A is equal to gm by r square. Can be taken as equation number 4. The acceleration produced by the earth is known as acceleration due to gravity. So equation 4 which becomes G is equal to gm by r square can be taken as equation number 5. How it becomes G here? It is what we call the normal acceleration. Here it is acceleration due to gravity. Therefore we just replace this A by G, small g. Small g is equal to gm by r square. Then put the values of universal gravitational constant, mass of earth and radius of earth. Means substitute all these values in this particular equation. Then you will get G is equal to 6.67 into 10 raised to minus 11 can be written as 6.7. For mathematical calculation, you can use 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Mass of earth m is equal to 6 into 10 raised to 24 kilogram. Radius of earth r is equal to 6.4 into 10 raised to 6 meter. So substitute all these values in this equation. Then the equation G is equal to 6.7 into 10 raised to minus 11 into 6 into 10 raised to 24 whole divided by 6.4 into 10 raised to 6 whole square. So after calculating these quantities, you will get small g is equal to 9.8 meter per second square. It is acceleration, therefore the unit which becomes meter per second square. Value is 9.8. Therefore acceleration due to gravity G is equal to 9.8 meter per second square. It is the value. Clear? Yes. Next one, variation of G, which means what? The value of G depends on the values of universal gravitational constant, mass of the earth and radius of the earth. And among these quantities, G and M are always constant. Clear? But in the case of R, it is not same at all the places on Earth's surface because Earth is not a perfect sphere. If the Earth is a perfect sphere, then the radius will be equal in each and every point. But here, the Earth is not in the shape of a sphere. Therefore, R is not same at all the places on the Earth's surface. The radius of Earth at the poles is minimum. Therefore, the value of G is maximum at the poles. So, these are what we call the poles, right? Yes, North Pole and South Pole. Here in this case, the radius of Earth at the poles is minimum. Here you can see the radius is less in the case of pole. Center to pole, the radius is less. Therefore, the acceleration due to gravity is maximum at the poles. Why it is so? Because here this acceleration due to gravity is inversely proportional to the radius of the Earth. Okay, yes. At the same time, the radius of Earth is maximum at the equator. Therefore, the value of G is minimum at the equator. Here in this case, in the equator region, the radius is maximum. Therefore, the value of acceleration due to gravity is minimum at the equator. Clear? Yes. The value of G is maximum on the surface of Earth and it decreases on going above the surface of Earth or on going inside the surface of Earth. Means acceleration due to gravity is maximum or the small g is maximum on the surface of Earth. If you are going up, then acceleration due to gravity decreases. If you are going inside the Earth's surface, in that case also G decreases. Clear? Yes. So these are the important points in this slide. Next, acceleration due to gravity does not depend on the mass of a body. We know that the equation is G is equal to Gm by R square, right? And in the above formula, G involves only the mass of Earth. Here you can see that the capital M is called the mass of Earth. Means it involves only the mass of Earth, not any other bodies. It does not depend on the mass of the body being pulled. Therefore, all the bodies fall with the same acceleration towards the surface of Earth, which means it is independent of the mass of the bodies. Clear? Yes. Therefore, we can say that acceleration due to gravity does not depend the mass of a body. Clear? Yes. My dear students, please watch the video carefully. After that, you must read the textbook, then write all the points in your notebook and study well. Thank you so much for watching video.